Okay, chapter 3 here. This is all about technical sketching. Now, there's a lot in this chapter that I don't go over. All right, there's a lot in this chapter I don't go over because I'm focusing on the things in terms of mechanical design, what you're going to find are most helpful. It is also going to be kind of that first stage of getting your ideas down. And you might think, well, what's the big deal? Why do I have to know how to sketch? Because a lot of times when, for instance, you might be making a change to something, you might be giving somebody an idea or an initial go at could you make a part that's similar to this? You might not want to take the time to sit down at a CAD system and make it formal and all that kind of stuff. Just like, let's try this out really quickly. And that is going to be something that you're going to utilize a lot. Okay. Also, before you are starting, to maybe create a more complex, especially model, you're going to want to like sit down and sketch it out first. So I want you to have, you need to have kind of these ideas of sketching behind you. So this chapter formally goes over that. Now, again, we're going to focus on certain sections that are more applicable than others. So we're going to be, looking at some shapes, defining some terms, and then also, actually doing some sketching. So why is it important to sketch? So I kind of started kind of introducing to this. First of all, it's a valuable tool that allows you to communicate ideas very quickly and accurately. Okay. A sketch is worth, or like we say, a picture is worth 1,000 words. You can sit and explain to somebody what you want. You can maybe point at things, but if you can sketch it out, all of a sudden things become more clear, as we know. Sketching is an effective way to plan a drawing and record any notes that are needed as you create complex objects. And when you take the time to sketch ahead of time, ahead of making a CAD model, for instance, you complete the design sooner because you have a plan of, how you're going to do it. And additionally, you have fewer errors. Okay. So it's kind of like, just like anything else, if you take the time to plan, all of a sudden things go a little bit better. And sketching is part of that planning process for a design, if you would. So as we're looking here, this is a good place too, to kind of introduce us to some, if you would, definitions and types of things that we're going to be encountering. So understanding solid objects. So many times when we are designing and we're trying to, again, sketch something, it's in terms of we want to make a part or we want to change a part. And that part is usually something that's solid. Now, a solid object is going to be bound by different surfaces and edges coming together. Sometimes it's going to be, a single plane. Sometimes it's going to be a curved surface. So you can see that solid object wise, we can have things look in a number of different ways. Okay, so it says we have planes, we have curved surfaces, double curves. That's what we see here. And then lastly, maybe a warped or a contoured type of a surface. Okay, so regardless on how complex that is, you're still going to have to try to generate some sketches in order to convey your idea in a way that people will understand. Okay. Now, other types of solids that we have here, these are regular polyhedrons. Okay. So some of them you've encountered or maybe even call something a little bit different, but formally, you'll notice we have a tetrahedron, we have a hexahedron, we have an octahedron, and then I don't even try to say these last ones. If anybody plays Dungeons and Dragons, these are going to be those types of things that those dice are, right? Push the door, please. Huh? You guys didn't hear it. You didn't hear it. All right. It was just me. Sorry. All right. So those are other formal types of solids. Next, we'll see some prisms here. Again, these are also things that you have probably encountered and maybe called differently, but formally they are prisms. And you'll notice that we have, you'll notice that a prism has two bases, meaning that they're parallel. So you can turn them two different ways and they still essentially are the same shape. As we go down here, I did cross these off because on this slide that the book manufacturer made, it got on there. And the bottom ones are actually considered pyramids. Okay, so you can see here that pyramids are going to be a combination of a solid base, planar, but then it's got those triangular types of sides that are going up and can be a right right square that it's kind of like they say truncated here or cut off at an angle. And then additionally, we have an oblique. Then we've got cylinders and cones. So a cylinder is going to be a single curved exterior surface. So you'll notice here that the cylinder has, you know, like a round top, a round bottom, and then it's going to be connected in the middle with the two surfaces that are going to go around the outside. We can have a right or an oblique. And then you'll notice that a cone is going to be one that starts with a, if you would, at the base here is a larger circle and then gradually gets smaller and smaller, whether it goes to an actual point or again is truncated in some sort of a way. And then we've got spheres. So here you're going to notice that we have now circular surfaces going around the entire, and there's no like straight surfaces on here anymore. So a couple different objects there. Now, as we look at items, there's some terminology that is going to kind of come up with any type of a solid that we look at. So first and foremost, we have edges. Edges are where we're going to see faces or surfaces come together. Edges are important to us when we start sketching because they are going to identify boundaries for us, okay? And then when we actually sketch those, they're going to be solid lines and they're going to be more pronounced than other things. So if we see an edge in a sketch or in a view that we're looking at, we're gonna know that that's a major element, if you would. You'll notice that we have faces here. Faces are going to be surfaces that come together, okay, to create the shape. Vertices are where we have edges that are coming together. So the pointed portion. So the little, if you would, corners are going to be vertices. And then points and lines. So points are going to be any point where we can identify like maybe an intersection of a line or two or three. And then a line itself is just going to be that straight element that we see. So we see a number of different lines, points or vertices, and then also faces here. Now, as we look at points and lines, again, a point is used to represent a location in space, but it doesn't have a specified width, height, or depth. It's just a point, right? It's like, it's just right there, okay? Now, a point can be identified along a line, just a point in space, or it can be at the intersection of, in this case, two lines, okay? A line is going to be used on drawings to represent edges of a solid object. So a line is going to be just that. We know what a line is. It's a continuous line and it's going to be solid, okay? And again, like it says here, it's going to represent in many cases edges of solid objects. And so because of that, we're going to be using them a lot. Now, an angle is going to be used to form kind of a dimension between two intersecting lines, okay? So the common symbol for an angle is going to be kind of that, either that less than symbol or the one that you see here that's drawn kind of at an angle and then a horizontal line down below. We've seen that symbol many times in math, okay, that you've encountered along the way. So as we look here, angles are going to be called out with their number and then a degree symbol in back of them. Now, when we are looking at, for instance, CAD, we can drop in our dimensions and it'll automatically, if you would, dimension to the angle that we drew it at. So if you drew it to a specific angle and you dimension it, it's going to show that dimension to be accurate to whatever you drew it to. Sometimes we go through and we add dimensions like, wait a second, that's not what I drew it to. Well, it is. It's gonna reflect exactly how that model was drawn. Any dimension, not just angles, any dimension. You'll notice here that the dimension for an angle has two curved lines and then arrowheads. Those arrowheads are going to identify where it starts and where it stops and what the angle in between is going to be. Now, drawing sketches, I think this should be. The following are important skills that we need to keep in mind for sketches and drawings. So accuracy. Now, when we sketch something, the accuracy is going to be, as you know, depending on the types of instruments that we're using. If we're using scales, we usually can be pretty good to the 32nd, 64th of an inch, if you would, whatever the increments of that instrument are. But in true sketching, in engineering, we want to make sure that we're representing the object, giving good perspective, And then probably adding some line or some dimensions to things to add to the accuracy of it. But we want to represent it in a way that's going to make sense. Sometimes it's going to be scaled. Okay, so if we draw it on, for instance, an 8.5 by 11 piece of paper, and the part is much bigger physically than that, we're going to scale it. But proportionally, we want to be sure that our representation, even though it's a sketch that isn't, you know, scaled perfectly or drawn perfectly, it's going to be a good representation of it. Speed, time is money in industry. So you want to work smart and learn good techniques so that, number one, you can convey your ideas with a sketch, not that it takes you hours to develop this perfectly drawn representation. You want to be kind of like, sketches are good enough. Let's go and get the information so we can move on and make whatever change it might be. In CAD, you want to start developing, and this is why I give you a number of homework problems, you know, each week in the CAD portion of this class to reinforce that, but also to build up your confidence and your speed. Okay. Now, this is not a race ever. This is the learning process. But as I prepare you for going out in industry, the expectation is you can kind of sit down and be relatively efficient in creating these things and be accurate with it. Legibility. So a drawing is a means of communicating with somebody else. And through that, just like when we write, if we use our manual penmanship and we need to write a note to somebody, they need to be able to read it to understand the message we're trying to convey. When we're sketching, it's the very same thing. We want to be neat about it. We want to use erasers. We are not going to use pens. We're going to use pencils because inevitably you might have to change. You might have to erase. You might have to change your proportions a little bit to make it more understandable and clear. So it's very important that you get the right information and you want to communicate it clearly. And then neatness. If a drawing is to be accurate and legible, it must also be nice and clean and easy to read. Okay. Sometimes you just have to start over because when you get to the end, it's not neat and it doesn't look good. But remember, a famous saying that we're gonna keep kind of coming up with as we go through, even in CAD, it came up I think on Friday. It's fine. The second time you do it, it'll just be faster. Okay. And actually, that's a great learning tool when you're in that process of learning things like a complex software. You go through it once and you kind of muddled along and you got through it, and that's what you did. And at the end, oh, I've got a good drawing. I encourage you to take the time to just draw it again. And you'll see how much faster you are as you do it that second time through. All of a sudden, oh, you now know what to do. Now, it might be because of the mistakes and the muddling along that you did previous to that, but that is part of the learning process. You'll gain more confidence and you'll also gain a little bit more speed as you go along too. So don't be afraid to start over. Sometimes you need to. I like to tell students too, when we are creating drawings and or sketches, we are doing it one time. We are doing it one time. And that part could be made 3,000 times, 30,000 times. So by doing it right the first time, taking the time to be accurate, taking the time to be neat, taking the time to make sure that it's readable and clear is really important. Okay. What did I tell you guys the first day of class as a designer, as we're creating things? What about that drawing in terms of its role at a company? It's for communication. What about its level of importance in a company? Yeah. It is one of the most important documents that's created. Now, I don't say that to kind of make you nervous about being a designer. It's an important job, but also take it seriously. It's not like I'm just putting a drawing out and, you know, hoping for the best. Okay. There are key elements on that drawing, and starting with how you lay it out, how you show it, the lines that you're going to use, how clear it is, how, you know, readable and neat it is. Now, all of a sudden, when somebody can look at it and take it and run, time is money. If they have to come back and forth and ask you questions like, this dimension is missing. What did you mean by this? No, what, you know, all that kind of stuff, or this feature is missing, where all of a sudden, time is money. Always think of that. If somebody's got to come back to you, they're away from the machine, they're getting clarification. And when that machine is down, that's costing money for the company, right? So So again, it doesn't have to be perfect the first time, but you always want to put your best foot forward. It's not something that you just, jot down and throw out there. Okay. So hand sketching, freehand sketching. Freehand sketchings are a helpful way to organize your thoughts and record ideas. They provide a quick, low-cost way to explore various solutions to design problems so that the best choices can be made. A lot of times in the process of creating a new product, it's not just, this is the direction we're going in, let's all run with it. It's, let's all get together. And here is the problem statement. Here is what we're trying to do. Here's the improvement we want to make. Let's all brainstorm and figure out ways that we think that this can be accomplished. So it's not, you're not just, coming up with the best solution, one person, and then going with it. It's a collection of ideas of people in different departments, probably, maybe not just in engineering, maybe some in manufacturing, some, on customer service side of things, maybe in marketing. And then all of those kind of thoughts and perceptions come together to make the best idea. So when we sketch, it's important to be able to relay that information, clearly, so that either everybody's all on the same page, or here's one of our viable options that we can choose from and have a good idea of what it is. So you'll notice here on the sketch that we have, again, this would probably end up being at some point a CAD sketch if it's going to be something that's going to be, officially manufactured. And you'll notice here that we have the outline of the part. This is going to be what we're going to understand to be a top view of the part. This is going to be a front section view, if you would. And then you're going to notice that there are holes, the hole call outs. It has dimensions. Okay, not on a drawing board. It tells us a little bit about the material that's going to be created. But as you look at this, can you read the dimensions? Yes. Can you get an idea of what this part looks like? Yes. Can you see that, the circles are probably going to be holes? You can start getting some good information about this, even if it's not in its final form. This is the type of sketch that we're looking for you to kind of aspire to, if you would. Now, if I'm going to go back to this. If you kind of know that, I have a hard time creating straight lines just by drawing it like this, it's okay to use straight edges. Okay, it's okay to, get some of those aids or circle templates and stuff like that. That's no problem at all. Okay, so don't think that I have to perfect my craft at drawing a straight line freehand. But if you can do it, it's okay too. All right. Now, techniques on lines. Okay, so the chief difference between drawing and freehand line lies in the characteristics of the lines. Now, the same, we call it the alphabet of lines, is going to apply. So for instance, if we have what we call an object line, visible line, one that's used for edges, as we've talked about, that's going to be a solid line right here. We call it a visible line. And you'll notice as we look at all of the different lines here, it's one of the darkest lines because of the fact that it's going to define edges where things come together. So we want that to be the most prominent. Notice that in the background, there's construction, or above it, there's a construction line. That's real light. It's still a solid, continuous line, but it's light. And it's there for exactly that, just to kind of get us, here's where we're going to start with this. We're going to notice in AutoCAD, when we look there is a construction line that we can actually lay down as well. So this is the difference between a visible line, actual object line edges, and then this is a construction line. It can be in the background when we sketch, but it's not going to be something, we're going to kind of ignore it, even if it's there. The next one is a hidden line. A hidden line is going to be dashed lines, evenly incremented as we go. A hidden line is going to be identifying a feature that we don't necessarily see because it's inside of the material. So holes, for instance, we usually don't see those when we look at a view. So back up here, well, this is a section view. So a section view takes a cut through it and we see the edges of the holes. But if we didn't create a section view, as we look through the front of that part, we would identify that as we're recognizing that the features are there, but we're going to show them as dashed lines. The next one is a dimension line. Dimension lines, you'll notice, are going to have our number, the size, and it may be in metric, it may be in English units. And then you're going to have lines with arrows at the end of them to show where that dimension starts and finishes. Okay. A dimension is always going to have 2 arrowheads, always. Okay. Now, I want you to notice that a hidden line, a dimension line, is a lighter, or it's a less line weight. It's a thinner line weight than what the visible line is. Okay. Again, the visible lines are the star of the show, the star of the view. Okay. Then we've got extension lines. These are going to be where our dimensions go to. That'll make sense as we kind of get to dimensioning and laying out drawings in the next week or two. And then we have a center line. A center line is going to depict, number 1, where the center of a circular object is. It's going to be a short line with 2 longer lines on either side, then another short line, long line, short line, long line, and so on. Okay. They're also going to connect circular features that are in a pattern. So as we look here on the top, notice that we have long, short, long. This is a center line connecting 2 features that are circular, but in line with one another. So they would share, if you would, that same dimension. Then we've got a phantom line. Phantom line can be used for a lot of different things. It can be used for maybe showing an object in a new place, like showing motion on something. Okay. It also can show things that you want to be aware of, but aren't part of this drawing. So like on an assembly, for instance, if I draw a machinist vise, I may draw it, and on the bottom, I have a phantom line that's depicting the surface of the machine that it's going to be on. So if I'm going to use it, I don't want to go anywhere down below that surface because it's going to interfere with something. So a lot of times in assemblies, we will show phantom lines for like, be aware of this because it could cause problems, or you want to be sure that as you're designing, you're not interfering with, something that's a part of the machine. And then the last 2 that we have here, these are what we call cutting plane lines, and they can be done in 2 different formats. You can either use a dashed line or you can use a phantom line. And these would be used to show where we were cutting through so we can see interior elements on a particular part. Okay. Now, again, notice the different line widths. Our visible and our cutting plane lines down here are going to be ones that have the darkest, the thickest lines. The other ones are de-emphasized, so they're of lesser line weight. Okay. Now, as we look up here, do you kind of see that come through? Now, again, it's sketching. It's not perfect, but notice that our visible lines in this top view are the darkest ones. Okay. Notice that the center lines and the dimensions are going to be a little bit lighter. Okay. That's by design. Okay. But notice that the tops of these holes, those are considered visible lines too. They're of the same line width as the edges of, excuse me, the rectangular parts of the view as well. Okay. So this alphabet of lines is you're going to see this again. Okay. And we're going to continue to, you remember and reinforce this as we create drawings. So here we've got some good and poor techniques. So just kind of giving you, I think it's always a nice idea to be able to be like, okay, that's what I'm going for, but not this. Okay. So here you're going to notice that the top line is valid ways of showing this. Now, the reason that it's grayed out a little bit is just to give you the idea that this is using a pencil rather than like a CAD software or a pen or something like that. So you will have a little bit of, differences in there. Down below, you're going to say not like this. Okay. You're going to notice that they're, you're going to try to be as even on your line width all the way as possible. But here you can see that there's, sloppy corners, if you would, and things like that. Now, again, we are not doing drafting by hand manually. We're practicing good sketching techniques. Okay. Line weights. Okay. So as we're using a pencil, this was one of the reasons I got into mechanical design, because I was excited that I would be able to draw all day. And one of the things that I got to do, because when I think I shared this with you, when I was in school, it was that transition between on the boards, big drafting boards where you got to draw all day, and make manual prints. Okay. And on pieces of paper on vellum, and switching it over to CAD. okay? Which was really an opportune time for me, okay? Because that new technology that was coming out, companies were embracing that, and I got to be part of that. And that's really what my first job was. It was being what they called a CAD operator at that time. I took manual prints, put them on the CAD system, all right? But when I was in school, I got to buy all these different pencils and these leads and all these erasers, and it was amazing, and brushes, and it was fun, and templates and French curves, because you needed that to manually create these things. So what you'll notice here is when you're doing the sketching process, you're going to get sharp lines. They're going to be thinner line width when you have a real sharp pencil, okay? But as that pencil dulls, you kind of go through that medium, and then finally to more that thicker line weight, okay? But then you get to a point where if it gets too dull, you can still get thick lines, but they're not going to be as pronounced. So you'll notice that on the top here, it speaks to, okay, when you have a really sharp pencil, that's going to be like dimensions, extension lines, center lines. When you're at the medium, that's going to be about a hidden line. And then when you're at that slightly dull, but not super dull, now this is going to be your visible line. And we all kind of, as we print and we write, we kind of feel those transitions, okay? But that's kind of where the line weights are going to line up with the elements that we talked about. Sketching straight lines. Here I said earlier, now these are some actual tips on being able to do it, but don't ever be afraid. I mean, we say freehand sketching, but don't ever be afraid of just pulling out, a straight edge and using a straight edge. And a straight edge can be folding your paper over and creating a straight edge that you can just follow. Totally fine, okay? You don't have to get an official scale out that has graduations on it, okay? But some of us are just good at it, okay? I'm okay at it. I used to be real good at it, but I don't do manual sketching and drawing as like I used to. Maintaining proportions. This is going to be important. So as we're looking at an item, I'm going to go back up to the drawing that we had earlier. Notice that this drawing, you get the sense that they didn't take a scale and measure this out at 2.5 inches high, or 2 1/4 from one edge is where that's going to be. But you get the feel of proportion here, don't you? Okay, that's what you're going for. So again, it's not about the dimensions lining up with exactly taking a scale and then measuring it and checking it. It's about, is my longest dimension literally the longest dimension? And in proportion, are my mediums and shortest look to scale to what that longest dimension is? Okay, so you'll be practicing that on the items that I give you to do. Okay. So really just kind of proportionally putting things in place without being completely, measuring it out. Now, it says here, let's see, let me go about, frequently a single view is going to be enough to convey your information. So for instance, if I wanted to draw this pencil, all right, I would just draw the pencil, the length, kind of the way that, it goes to a point in the front, and then, draw the different elements that are along the way. Okay. And one view, if I look at this and I look at it, one view is probably pretty much gives me almost all the information I need. Right. And that's the case in drawing. You want to create as many drawings that are needed to convey the information that you need. So for instance, you're going to notice here that we have just one view of this part. In this sketch, it doesn't tell us what the part is, but there is a note. It says the material is a 1/4 inch brass. What that means to me is it's a 1/4 inch thick piece of brass, and this is the profile that we're creating from it. So if we would look, if you would a side view or into the page, it would be a 1/4 inch deep all the way around, like a little sheet, if you would, that would be making this out of. Okay. So now it says at the bottom here, let's sketch this part together. All right. Now, we're not going to use any pens. We're only going to use pencils, and I'm going to give you some graph paper. I have it here in class. So, so if you are following along and you don't have, and you happen to be off campus and you don't have like graph paper, I'm just going to be using, just regular graph paper. I'll be handing some out here. Just proportionally, make the drawing. So I'm going to take time too. I'm going to pause the recording right now, and I'm going to I'm going to pass out paper for you guys and pencils for those who need it. And then we'll kind of reconvene and we'll be back to walk through this process. So I'm going to. Okay, so we are going to go to page 79 in our book, and we're going to walk through this process of creating this sketch. Okay, now this is, I want to make clear, this is one way of doing it. All right, you might jump in and do it a little bit differently, and that doesn't make it wrong. It's just that the final elements, the way that they're going to be drawn, is going to be the important part. Okay, so if you take a little bit different process, that is okay. So I'm going to go underneath my camera here, and you're going to notice that on page 79, here's that drawing that we just saw on our PowerPoint. I'm going to zoom in. Okay, and what they do here is they have a piece of grid paper just like we have here, and they're just are kind of going through this process. Now again, I am not expecting you to maybe follow it exactly the way, but how they've kind of laid this out is they first identified where the center lines are for the circular elements. Notice that we have this larger radius on the outside that shares the center of like what I see as a through hole. Okay, the next circular element is here, and then the last one over to the right is going to be that same size, and it's going to have another diameter here with a smaller circular radius on the profile. Now again, as we look at this drawing, I'm going to zoom in here. A couple of things that we have not yet really focused on. Number one, you're going to see a symbol that is a circle with a slash through it. That signifies a diameter. Okay, a diameter is going to be the dimension fully across from one end to the other on a hole. Radius is from the center to an outer edge. So 2 times the radius is equal to 1 diameter, right? So that symbol right there is that symbol right there is the diameter symbol. Then you'll notice in front of it, it says 2x. That means 2 times. Okay, so then we're going to look, where is the other hole that looks just like this? And you'll notice that it's over here. Notice that there's not another dimension on the other hole by design. Okay, and we'll talk about dimensioning rules later. But for instance, if we change the size of this hole, and it's always supposed to be the same size as that one, and this had its own dimension on it, if we go back and we do a revision on this and we forget to change it in both places, that's bad, right? Because now we're going to get 2 holes that are going to have 2 different sizes that are intended to be the same. By putting the 2 by up there, holds them together. Okay, so that's where they started with those 3 center lines. Those are kind of like, 3 elements that are on there. Okay, now you'll notice that the dimensions here, okay, they've got, from one to the next, it's 96. And then as we go to the other one, it's not, is it perfectly in the center? 48. Yeah, it is, right? Right between the 2 is going to be the diameter of 8 millimeters. And you'll notice that they have each one of those marked off. Okay. Then what they do is they're going to add. Now, I will say at this point, this is construction line mode. So the lines here are kind of like in the background. It's kind of like you're sketching them in place, like they're going to be about here. All right. So that in the event that you need to erase this to keep this neat, it's not hard to erase it. They just disappear and you just put them where you need them to go. Okay. So that's the whole point of construction lines. Don't be afraid to use those. Okay. Then you're going to notice that at the bottom here, they have more construction lines kind of showing the height and the length. Okay, in relationship to those center lines. And then you're going to notice then they progress up to number 3 here, where they put some circles in place. Now, if you wouldn't have to put a full circle here because you're not going to use this part of it. This is going to be what's left. Okay, but again, we're still kind of in that construction mode, starting to make things a little bit darker. Okay, and then lastly, you're going to notice that you go over the top and we put our visible lines in place. Now, at this point, you'll notice that they leave their construction lines in the background. Okay. Now, I will tell you a little bit about that. So years ago, when we used to do it on vellum, and you would leave those construction lines, but you would make your visible lines nice and dark. Okay. They actually on a blueprint machine wouldn't come through. It wouldn't copy. They weren't dark enough, if you would. Okay. So when they made copies, you wouldn't see that. But as you can see on here, you can. So it's not wrong to erase those out. And I probably would, like any of those corners and that kind of thing. Bless you. Okay. Now, all I want you to do is really just sketch the actual item here. You don't need to put the dimensions on. All right. You don't need to put the dimension on unless you really want to. That is kind of fun. So I'll kind of walk through this process, mimicking what they did. I'll probably, like I said, there's variations on this, but ultimately we want to get to that final clear drawing. So I like what they did. I'm gonna kind of go in the center of my thing here. I'm gonna kind of count 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13. I'm gonna go 20. You could do an even increment. And then that means that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is going to be my center. Okay. So I'm just going to kind of mark those centers. You could do the full lines. That's totally fine. And then I do like the idea of the height. So the height of this is a radius. If you'll notice, it doesn't give us a height dimension from top to bottom. It's dependent on this radius here. So that means it's going to be 30 above the center line, 30 below, 30 above, 30 below. And as we look at this proportion wise, 60 is going to be about 2/3 of 96, right? So proportionally, we want to put that in there. We want to kind of make it, look. So maybe about here-ish. And 1, 2, 3, 4, 5, and then make it even 1, 2, 3, 4, 5. Okay, so right about like that. Now, again, not being exact proportions, but what's nice about as you can see already, using the graph paper, now I can make it look even on both sides, because then that's really the intent that I have. If you don't have graph paper, that's okay. And again, then you just want to maybe mark off and do a little bit of make sure that it's even. And then I'm going to do a radius. Now this is the trick. If you have a compass, I don't have one handy today. If you have a compass, you can put your compass at the middle here and strike that arc, right? You can do that. Or we're freehanding it today. So that means that if I want this arc to be created, some aids that you can do, you can go 1, 2, 3, 4, 5. However far you went on one end, I'm going to go out 1, 2, 3, 4, 5. And I'm just going to put a point right there. That gives me something to kind of go for. All right. So that means from this point to this point to that point, I'm going to strike an arc. Okay. Now, again, freehand sketching to get the idea across. So there is no judgment here at all. So that's going to be one side. And this is going to be my other. Nope, not a full perfect radius, but looks circular-ish. The next thing we want to do is we want to put the hole in the middle here too. So I'm going to kind of do that very same thing, go 2, 2, 2, and 2 to kind of have something to go for. So I'm going to hit that radius there, 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 and there. Then as we look, see again, I'm going in a little bit different order. As we look, the next point is going to be just past that middle center line that we had. So we want to make sure, again, proportion wise, that we want to hit this a little bit past. So I'm going to draw my line along here to be to that point. Okay, same thing up on the top, line right there. Okay. Now, if I wanted to, at the middle here, I could add my smaller hole. Okay. And then as I come down, you're going to notice that there's a little radius or a fillet here, and it comes down. And now we're going to add that little shelf in there. So it's going to come down. I'm going to go down 2. I'm going to mark my little points here. So I'm going to come down here and here. Now I am going to be adding a radius in a little bit, but I'm going to make it a sharp corner right now. And then I'm going to go to the top of this center line, because this is going to be, if you would, the end of my line on the top. And then I'm going to create that radius. So I'm going to go to the top of that center line, okay? And this is where, again, the grid kind of aids for making the straight lines because you don't have to be perfect, but if you did want a straight edge, feel free to, like I said, bend over a piece of paper to create that straight edge. And then here you'll notice that I'm 1, 2, 3 out. So I'm going to go 1, 2, 3 here. And I'm again going to try to, oh, that's not good. Again, that's why we have erasers. There we go, something like that. There's my radius on the end. And then I need to draw my circle, hopefully. And then lastly, I'm going to go in and I'm going to make my little fillets here. So I'm going to get rid of my corners, my sharp corners, and try to represent as best that I can those radiuses. Okay. And all the features, I think I did. So this is what mine looks like. Now, it is by no means perfect. But if I started adding some dimensions, some notes here, for instance, I think I could get the idea across. You know, like I know my holes aren't perfect, but if I would say, oh, this is a radius of R30. Okay, now you know what that is. And they know that even though it's not drawn perfectly, somebody who's going to make it could machine it or cut it out and make sure that that radius is held. If I would say, oh, there's 2 holes that are this size, notice that my 2 holes that are about the same size are about the same size. I don't have to be, you know, if you make one really small and one larger and say 2 times, it's like, wait a second, which 2 are going together? At least here. And that's because of the grid. So these were 2 times diameter of 19. Okay. So you could continue to add dimensions. I'm not going to make you do that, but by adding then those details, the sketch now becomes more clear. Would you agree? Okay. I want you to practice really just doing the sketching side of things. Okay. Any questions kind of on that process? All right. How many kind of like the manual drawing and sketching? I think it's kind of fun. I know. Like I said, this was what I was hoping I'd get to do. I did it. Yeah. You know what? And that's what's happened to me too. Years ago, I used to be really good at this. I used to be really good. I used to have beautiful penmanship because of like this. We had to practice our penmanship and you would, you know, put all the dimensions on. And I had beautiful penmanship and skills. But then, like I said, when I got out in industry, I just did CAD. And when you start, you know, typing a lot and using CAD, do you guys notice too, your penmanship isn't quite as good as it could be, right? Any questions? Now, in the book, they do a lot of, you're going to notice that there's a lot of pages on isometric drawings or pictorial drawings. We're not going to do that. And the reason we're not going to do it is because from a sketching standpoint, you're never going to sit down and, well, you might, but you know, you don't have to be perfect at sketching, you know, the thickness of something, because when we start doing modeling in Creo, for instance, or if you've ever used SolidWorks or Fusion 360, I know there's some students that have experience with that. You have that ability, even when you make the drawing and you lay it out flat like this so that you can put the dimensions on it and look straight on. You also can put an isometric up in the corner. And that then gives another level of clarity, if you would, to the drawing. So because we have that automation that is created by, you know, typical tools that we're going to be using, we're not going to worry about creating that perfect isometric. Okay. If you want to go ahead and read those sections, I encourage you to, but you won't be responsible for it in here. This kind of stuff goes a long way in conveying your ideas. Okay. All right. Then I am going to go back to our PowerPoint. What would oops, no, I'm sorry. Get this out of here, minimize that. It's actually in my thing here. Okay, one view drawing. Now, the next thing that they're introducing us to is projection methods, And there's a couple different projection methods that they're identifying here, and they really have to do with how we're looking at whatever object we're trying to draw. The first one here is called a multi-view projection, meaning I'm going to look straight on to my part in one view, and then I'm going to look straight on in another view, and then straight on in another view. I change my point of view, and each one of those points of views are going to be changed by 90 degrees, okay, depending on the perspective. So if you've ever, you know, and I think a lot of times in high school or in industrial arts classes, you know, students a lot of times want to draw their house, or, you know, kind of have that architect type of feel where I want to design the inside of my house, or I want to design the outside of my house. And you stand, and the perspective that you're given is you're looking either straight down inside so you can see on top of the walls where the separations would be, or you might stand right outside the front of your house or a house and then draw what you see. Then you're going to stand on the side of that house and you're going to draw what you see. Or you're going to take the perspective of being in a plane on top of your house and look down on your roof. Those are multi-view drawings. I'm taking a different perspective that's 90 degrees to where I was at to actually look and draw what I see from that point of view. Okay. The next one that we see here, or actually the other three that we see here, are going to be those isometric type, or what we call pictorial types of views, that are going to give you at the same time, not just the front view, but a skewed view of, oh, the corner where I'm going to see part of the front, part of the back, part of the top. Okay. And so on. So you're going to take like more of that corner view. These again are going to be automatically generated for us in parametric CAD solid modeling software. So again, we're not going to spend time sketching and planning those. We're going to stay here with the multi-view drawings, because these are the types of perspectives that we're going to have when we create the drawings that we're going to do in mechanical design. So let's go to page 117, and let's do a little bit more practice on sketching. Okay, so I'm going to go to 117 in our book. And what I want to do is we're going to look underneath here. Okay. And on page 117, these are exercises, sketching exercises at the end of the chapter. Okay. So I want to just get a little bit more experience with this. So I am going to hand out a couple more pieces of paper here for those who are in class, and the ones that we're going to be looking at. So I am going to stop the recording or pause the recording momentarily, and we're going to be looking at B. Okay, A is really easy. We're going to be looking at B. Now, the perspective that we're going to be taking in each one of these is what I'm going to say is a front view. Okay, so I'm going to be looking right here, and I'm just going to draw a one view of the profile that I see. Now, we don't have any dimensions this time. So what you're going to do is you're going to create this by looking at the proportions, and you're just going to create a single view, just like we did before. The next one that we're going to do, I think, did it say, let me go back. We're going to do B, E, H, and I. B, E, H, and I. So going back here, so B, then we're going to do E, we're going to do H, and we're going to do I. Okay. So what I'm going to do is I'm going to get you guys a little bit more paper. You can turn over the piece, or if that you were working on, you can do one of these. This is just practice. Okay. There's no grading involved in this, just practice. And then what I'm going to do is I'm going to have you just get started on each one of these, see how far you can get. You might have some questions along the way, but then we're going to go over them together. Okay. So I'm going to pause while we work on that. Okay, so we're back, and we're going to start looking at each one of these. So the first one, I'm going to go underneath. The first one is B. Okay, so using that perspective of going, looking straight on in this direction, we're just going to draw kind of that, what I like to call the major shape of the part. So you'll notice that edges wise, it's around the perimeter, and we have that half circle in the middle. Okay. The next one, I'm going to go down to E. Okay. E here. It's that one right there. Now this one, we kind of have that recessed surface going back. And we also have a feature that is a circular feature, that drilled hole going all the way through that thickest part, right? So let's see how this one would look. So using that same line of sight, if you would. So you'll notice that we have the perimeter of the part. We do have a solid line here because that's an edge. When I look straight onto it, I look straight on, I am going to see that edge there. Okay. And then you'll notice that I'll see the, circular feature, the hole in this view going straight through. But I also recognize that there is a feature that I'm not seeing. And the feature that I'm not seeing is going to be the drilled hole that is going all the way through here. We see it in that view going down, but if I look straight on, I'm not going to be able to see it through that solid surface. Okay. So what I do is I say, oh, there's a hidden feature there. And you'll notice that this would depict the width or the diameter, okay, either side. And then we put a center line through it to let people know that's a circular feature. We only put center lines when we have a circular feature. Okay, that's showing us where that center line is passing through. Okay, if I wouldn't have the center line going through there, then it would be, for instance, like a square edge of some sort. Okay, that I'd have to then probably have another view to look at. But this tells me that's a circular feature going through there. Okay, questions on this one? If you didn't catch the hidden line part of it, don't worry. All right, that's why we're learning. Okay, now you kind of know, right? H. This one's up here. Now this one, let's look at the part itself. This one, you see the front face. This is all one face, but then it drops back for that ear, right? It drops back for that ear. So as we look here, pretty straightforward on this side, right? All the way through, but then we do see this edge and it's recessed back. Now we can't see how far back it is, but that edge in the front here lets us know that we're seeing an edge there of two surfaces coming together. So we have to depict that. Okay. Questions on this one? The last one, I didn't do too good on this one. Looking straight on. All right. Ugh. This is what mine looks like. But again, trying to perspective wise kind of bring it together. Now, again, adding dimensions would obviously add much more clarity to this. But as we look in that same line of sight as we have for the other parts, this would be what you would see. Any questions? You kind of get the idea. All right. How did we do? How do you feel about sketching right now? It's okay, huh? Kind of fun. I get the idea. It's a good introduction to laying parts out in visualization. So let's jump back to our PowerPoint. Right. Now, as I've alluded to, when we create models in CAD and not specifically in AutoCAD, right now, as you know, we're creating 2D drawings in AutoCAD, and AutoCAD is really reserved for that purpose. It does have capabilities of creating 3D models, but in industry, it's really not used for that anymore. The industry has gone to parametric software like Creo that you're going to be getting to work with. And when we use Creo, it creates what we call a solid model, and it's going to be more depicting, more, I don't know, I'll say realistic, the parts that we're going to be working with. Through that process, when you have a solid model like this is the reason we don't do the pictorial drawings, as I said earlier, the isometrics, because we can drop a view like this, which adds so much clarity to what we're actually looking at. So, so we do have tools a little bit later on. So this is just kind of a picture of, how we would use 3D modeling for, CAD drawings as well. All right, so that is the end of chapter 3. So I'm going to stop the recording right now, and we're going to take a break, give you guys a chance to kind of walk around a little bit, and then we'll be back and we're going to look at chapter 6 out of our book.